Hello and welcome to this section of the Extra Help with Derivatives tutor for Calculus 1. And in this section we're going to continue working with implicit differentiation. Last section we had a good few problems to get your feet wet, to show you how to use it, give you a little theory and background as to why it works. In this section we're just going to continue working more problems, a little more complexity, but really we just break it up to give you a little breather, make sure you understand the basics, and here we're going to go into some a little more complicated functions, but really it's exactly the same procedure. So let's just get right started and get some additional practice. What if you were given x squared plus y squared is equal to y squared over x squared. Now notice that this equation, it's not already solved for y. So if it were already solved for y, you could just take derivatives in the normal manner. But since it's not already solved for y, we have to use our implicit differentiation. So what we're going to do is just go left to right, taking derivatives of every term using the rules that we have outlined in the last section. And just to refresh your memory, anytime you come across an x term, since we're taking this derivative dy with respect to x, anytime you come up to an x, you just take the derivative in the normal way, all right, just like before. Anytime you come up on a y term, something like that, you take the derivative in the normal way, but then you have to multiply it by dy dx because you don't know how y varies with respect to x. You know how x varies with respect to x because it's itself, so you really don't ever have to write that down, but we have to explicitly write it out for these terms. So we look at this guy and we say, all right, derivative of x squared is just 2x. Okay, so far so good. Then we look and we say, well, the derivative of 2y would be 2y, the same exact procedure, subtracting 1 off the exponent, but then we have to multiply by dy dx. And this is the chain rule in action, and we've talked about that in the last section. Okay, and then on the right-hand side, we have a quotient. We have y squared over x squared. So we're going to need to take the derivative of this entire thing, but this is a division going on here, so we need to use the quotient rule. So what we're going to do is bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So what we're going to have is the bottom times the derivative of the top. What is the derivative of y squared? It would be 2y dy dx. Exactly what we wrote here. So this is bottom times the derivative of the top minus the top, which is this guy, times the derivative of the bottom. What's the derivative of x squared? Is just 2x. All over the bottom squared. So for right now, we'll write it as x squared squared. All right, so bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's how we did that. All right, now let's go ahead and simplify a little bit. There's not much to do on the left-hand side, so we'll just rewrite it. So we have 2x plus 2y dy dx is equal to. And then here we have 2x squared y dy dx minus 2xy squared. And on the bottom, we just have x to the fourth power. All right? So what we're going to do next is just simplify this expression. Now, what we really ultimately want to do is solve for this term, dy dx. So we need to manipulate this and collect terms on both sides so we can basically isolate and factor that out. So the biggest thing in my way is its denominator. So what I'm going to do is multiply both sides of this equation by x to the fourth power, so it'll disappear on the right-hand side. So we multiply by x to the fourth. Then on the left, we'll have 2x to the fifth because we're multiplying by x to the fourth, so we add